Okay, Julia,
Yes?
what are you making today?
We're making white flat house paint.
And so what's one of the first things you're doing?
You first label your
Container?
with your formula heading and then the date.
Okay, show me the formula there, please.
Formula?
Okay, so that looks like the formula that we're making, all right. White flat house paint. And what's the formula label?
WHP, white house paint, 1A.
Okay, and you put the date on the container also.
Mm-hmm. And you tear it.
Tear the balance, okay.
Now we need about 40.8 grams of water.
40.8 grams of water. And here goes the... Now, the first one you can always overshoot. And it's always hard when someone's watching you.
Mm-hmm.
Ooh, 40.4. You can always use a syringe.
Yes.
These are called disposable pipettes. They're very cheap. 40.8.
There we go.
All right, perfect.
Even though you can always overshoot the first one.
You can always overshoot the first one.
Okay. And then?
And then you check off.
Check off. I do check off. You added the water, so you check it off.
Okay. And what's next on the agenda?
Now cellulosic thickener.
Cellulosic thickener, right there. And how many grams of that?
That is 0.7 grams.
0.7.
So
Now, do you add it right to the water, or do you add it under agitation?
you add that under agitation.
That's right. Okay, so you might want to put that into one of those small paper cups there.
Right.
We'll put this on the mixer. Zero.
Zero. Always zero. What is this? And so now 0.7. Whoops. 0.8. Point 7.
0.7, way to go.
Mm-hmm. Okay. Okay. So now that we have that, and we'll check it off as soon as we add it under agitation to the water, or H2O.
Okay.
This is mixing medium speed 10 minutes.
So this is one kind of mixer, this drill press. This is a 1/3 horsepower drill press. You can put different size in the chuck here. This is another kind of mixer. It's actually a milkshake maker, but it has very small mixing blade. But works really, really well. But this drill press here with the adjustable pulleys, you can get different speeds. Right now, let's see what speed we've got. Turn it on and we'll see what it is. You think it'll throw the water out?
Probably.
Okay, we better step the speed down. Okay, so the bigger this is, the smaller it Okay, so we moved it down 2 notches, the pulleys, and now it's spinning less, and we can see that the water will not jump out of the container. Okay, so put this under agitation. Now this is a cellulosic thickener. What does it do?
It makes the water more gel-like. Increases viscosity.
Increases the viscosity. Cellulosic thickeners have massive amounts of OHs, which gives hydrogen bonding. Usually takes about 10 minutes of mixing. So we'll wait for 10 minutes while it's mixing.
A substitute or defoamer.
Okay, so what's your next item to add?
Defoamer, but we have to substitute one, and so we always shake up the defoamer because it separates.
Okay.
And so
what defoamer are you substituting?
the DFC 39
For the
024.
Okay. For the AD024, we're going to put in AD.DFC39 because that's a better defoamer.
Because that's the defoamer we have.
Oh, okay.
And we still will use 0.2 grams because it should work.
Okay.
And we also had put in the cellulosic thickener, so you check it off.
So now you're going to use the other method instead of the direct method. What
Yes,
you're going to use?
weigh by difference.
Weigh by difference.
So
Okay.
you have it on there, and you tear it.
Put it to 0.
Yes.
Okay.
And now, see, when you take it off, it will show how much is
Missing.
gone.
Okay.
And that's how much will be going into there.
Cool. Okay, use the weigh by difference technique.
Okay, should we put this under?
I think you just put that in, it won't shock it or anything. And you're going to put in 0.2.
Yeah.
Okay, so how many got put in on that one?
0.
0.
Ta-da.
Let's look. All right. 0.2 is missing. Good.
So you check that off.
All right. Okay, so now we're going to put in the grind aid.
Yes. So
How many grams is that?
that is going to be 0.8. I'm also going to do this weigh by difference. There we go. So see. Hold on.
You can leave it. It's stuck
Okay.
in the bottle there.
Okay, so that's 0.2.
0.2, so you need some more.
Okay. That was 0.5.
So usually you do this while the mixer's running, but
0.7.
it doesn't hurt right now. You don't have any emulsions or anything in there.
0.9.
Okay, so if you overshoot,
If you overshoot, you say plus.
put a little plus,
Yep, plus.
plus 0.1.
And then you say you put it in.
Good for you. And check off your 0.8 also.
Because you put both of them in. Oh! Actually, it's right between.
It's right on the borderline, but it's good to be
still,
good to be accurate as you can. Okay, now your 104E.
the wetting agent.
Right over there.
This one?
Yep.
Okay.
Here's some rags.
Good to use. Now for the wetting agent, we're going to put in 0.6 grams.
So let's zero it with the
pipette on. There we go.
okay, 0.6.
Oops.
Point 0.5. 2 drops. 0.5 still. It's a miracle.
I put some in, I swear.
0.6, good for you.
Wait. So,
All right, we're getting there.
I love titanium dioxide.
Okay, titanium dioxide.
I love titanium dioxide.
You do? Why?
I wrote a paper on it.
Oh, that's true. So how many grams titanium dioxide?
27.1 grams. So it is tarred, even though it doesn't act like it is.
So you're going to weigh it into a paper cup
Yes.
and then pour it in.
Because we have to add it under agitation.
So you add it under agitation so that all of the surfactants and everything can attach onto the surface more readily of the titanium dioxide particle.
Yes. 24. It's almost there. Just a few more grams. 27.1. Ta-da!
Excellent. Now we'll add that while it's spinning. I'll hold it.
There, 27.1 exactly. Okay. So,
Turn it on. And normally we can just tie this down with, you can see the whole thing is turning white.
that's what titanium dioxide does.
Yeah. Titanium dioxide is a pigment that scatters the light. It actually refracts the light so much that it refracts it back to us. It's not really a true reflection, it's more of a refraction. It's its mechanism.
There we go, it's all added.
Great, what's the next ingredient? We want to grind this now until it's ground.
So you say check off that you added. Now it is silica. That's the calcium.
Oh, I had the silica in a box. I'll go get it. Okay, now you're putting in.
Silica?
Okay,
I put in 0.9. Does that look like 0.9?
let's find out. Point 1.
0.1 to me. Okay.
Now this will keep it from sagging. This has a lot of...
I know.
Okay.
So, check that off.
Good.
Hey, look!
All right.
See, I'm good.
After it evaporates enough.
It's borderline.
Okay, what's next on the formula?
Thickener.
Thickener. I think you have some thickener right there to your right hand, right there. Nope, need to open it up. Okay, so you got the thickener open.
Yeah.
You should put the top on that other. Here's the top right here underneath my elbow. Alrighty.
Okay.
How much do you put in?
1.3 grams.
Oh, that's quite a bit. So you're just going to use what was stuck to the lid.
I'm going to try.
Better zero it with the stick in there. Okay, it's on 0. It's going to weigh by difference again.
So 1.3.
I'm not hitting the marker. There I am.
Not going in.
Okay, you can shove it in later. There. One 1.3, good.
Great.
Okay.
Looks good to me.
So what's your next, put the lid back on. What's your next item?
Calcium carbonate.
Ooh, calcium carbonate.
Which is in here.
That'd be the Camel Cow.
Yeah.
10.3, and then we'll put the same amount for the other one, so put 20.3.
So 20?
Yep. Use another stick.
Okay, so put 20.3 of this.
So the calcium carbonate, the purpose of it in the paint formula is to be cheap. They're usually only about 10 cents a pound. We sell paint on the volume, so if it has the right amount of resin, has the right amount of prime pigment, which is the titanium dioxide, then anything else that goes along with it just fills up space, still works okay. Calcium carbonate has slight solubility in water, so it's not the absolute best for exterior exposure, but it gets the job done. Very cheap.
Okay.
So now we're putting the calcium carbonate under agitation so that the surfactants can get all the surface area. You got it.
Yep, I got it.
Ooh, and it's starting to thicken up just right. Look at that. just as advertised. We might have to turn the speed up a little bit, because now it won't bounce out. So let's turn the mixer off. Normally we keep this tied down, but demonstration purposes. Okay, we'll take the pulleys, we'll move them up a bit. Move them up to the one next to the top here. Try not to pinch ourselves. Get second one down. Okay, now I'll turn it on. Ooh, it's a little faster.
Yeah. Now we need to put in
Okay, propylene
propylene glycol.
glycol is, see that SWPG to your right? And back a little bit. Now go right. Right there. Yep. SW, S stands for solvent. W stands for water immiscible solvent. PG stands for propylene glycol.
Great.
How many grams? 2.5. It's not too many. Of course, I'm back in. Now with industrial solvents, we can just pour it back in. Actually, you could go by difference with that, because some's going to stick to the container anyway.
Okay, so
Put it on 0, and put in 2.5. Okay, my batch here is starting to get warm because the higher speed and because it's viscous, so the friction of the blade is starting to heat up the batch. Now, in some ways that's good, because the hotter it is, then the molecules are vibrating faster, and the grind is getting finer and finer, divided faster and faster. Okay, you got it?
got it. So you checked off. I went a little
Okay, now we make sure that our grind is okay, and then we can put in our Texanol. So we have to wait about 5-10 more minutes. Okay, so one of the things we want to do while this is grinding is a lot of the pigment will stick to the sides of the blade and the sides of the container. We're not able to do too much because it's such a big blade, such a small container. Generally though, in the plant, we want to make sure we scrape down everything that's sticking to the sides, and especially the sides of the shaft there. That way the large particles won't stay stuck. That looks pretty good. Okay, time to put in the Texanol. Now, one reason we don't grind in the Texanol is because the Texanol will dissolve all of the surfactants that are on the pigment and strip the pigments of the surfactants. Okay, just use that DPMB. It's a close cousin. Now there's the vortex. The mixing blade makes a pattern of making the paint swirl up and down. There you can see the effect the Texanol is having. Very powerful solvent. So now the vortex is even more pronounced. So you got it all in? Okay, this strap here is in the way of the camera.
Whoops.
There, thank you. Great, I think we're ready now to do our final experiment. We have this made without resin. Final experiment, we put resin in it, and then we see the difference between with and without resin. So we'll take this off the mixer and blend it with the resin. Okay, we're on.
Got thick.
It got real thick. It won't even pour out. Wow.
Now.
So now we're on to our next batch. This one, we saw the viscosity is very thick, and the grind is a 6 grind. We could measure the grind with our grind gauge. Let's do that. Okay, so the formula says we should take a grind on it. Here's our grind gauge. Right here it's the Hegman 0, and it's microns on this side. And so we're going to put a small amount of paint, a little bit more, so we can...
Is that good?
A little bit more. So now this is like a trough. This is deep trough here, and all the way down goes from 0 to 8. And so what we'll do is we'll spread this paint out, and where we see the particles of pigment show up, that'll be called the grind rating. Normally when you got calcium carbonate, you can expect a grind of about a 6. Just straight up and down. And so we see, very good, very good. We see right about there. 6 grind. Good. Good, clean 6 grind. Okay, that means it's safe. We're ready now to add the resin.
So check off.
Oh look, I wasn't recording. Now I am. Okay, so you added the resin.
I added 1A.
I mean, you added the 1A, 30 grams. Okay. Thought I was recording. We better play this back, huh?
Yep.
Okay, we got now to put 12.1 grams of the resin.
Yes.
Alberdink Boli. There's 6. There's 7. There's 12. Okay, now we'll put that back on the mixer with the resin in it. And oh, this is a smaller, better just mix this with hand. Okay, this particular container here is too small. So a little bit less resin won't hurt.
Okay.
Not for this demo. Okay, so we're going to stir that in carefully, and then we'll make a drawdown. We'll make a side-by-side drawdown so that everything will be compared side by side.
Down.
Okay, so now we got 1A and 1B made. Yay for you. That wasn't so hard.
Mm-hmm.
So now we're going to do a drawdown.
Yep. So we'll have WHP1A here.
This is where we start labeling.
And WHP1B here.
All right, White House paint
And
1A, 1B.
The time is 11:50.
The date.
So it's and it is 11.
All right. So now we want this, what's called a side-by-side drawdown.
So, like so. So, right.
Very nice. Get a little more center so that they'll touch each other. You want them to touch each other. Good. There you go. We have a piece of plate glass underneath this drawdown card. And we're going to use a bar called a 3 mil blade. 3 mil means 3/1000ths of an inch of, you see the 1B, which has the resin in it? It's a lot thinner.
You can say that again.
Yep. So, didn't take too much to thin it out.
No.
Okay, it looks pretty good.
Yep.
So now, we'll spread it out. We'll catch from this plate glass. The reason we use plate glass is because the tolerances are so thin that regular window glass is curvy. So now Julia will just spread it out. Interesting thing about drawdown bars is that in order to put down a 3 mil, which is 3/1000ths of an inch, they're actually cut at 6 mil because half sticks to the bar and half sticks to the paper. You got it. Okay, so we'll let this dry and we'll see the difference.